Hello friends, this is Jim with Science Talk. I have a couple stories here about things moving and slipping and sinking into the ground. I'm going to start off with a story about Mount Etna. Mount Etna is slip sliding toward the sea. Mount Etna, Sicily's famously fiery volcano, is sliding wholesale toward the sea. The volcano crept an average about half an inch, 14 millimeters, a year toward the Mediterranean between 2001 and 2012. This creeping motion doesn't immediately raise the risk of danger from the volcano, which is already an ever-changing environment as it is, but of more concern is in so doing the mountain spewed ash and lava from a new crater that started in January 2017 and went through much of that year. As of January 2018, Etna was frequently burping ash and gases, according to the Smithsonian Institution's Global Volcanism Program. However, the mountain's slow slide could be bad news in the long term for anyone on the downslope of Etna, says volcanologist John Murray of the Open University of the United Kingdom. He submitted a paper, he and his colleagues, that can be found in the Bulletin of Volcanology Journal. The geological record shows that such sliding volcanoes are prone to devastating sector collapses on the downslope side, Murray and his team wrote. These collapses are rare but extraordinarily ruinous. Radiocarbon dating shows that Mount Etna has been a restless mountain for millennia. In its first confirmed eruption, according to the Smithsonian, was around 6000 BC. Ancient people left records of the mountain erupting as early as 1500 BC. Etna's current eruption is ongoing, and about 3 million people live within a 62-mile, 100-kilometer radius of the mountain. That's a lot of people very, very close to this mountain. Between its major eruptions, Etna widens, Murray and his colleagues wrote. Part of the expansion is due to gravity pulling material down the mountain's steep slopes. Part is because the mountain's magma chamber expands between eruptions. GPS sensors on the mountain have shown that this expansion is not entirely symmetrical, however. Murray and his team tracked Etna's movements in between eruptions using data from between 2001 and 2012 from more than 100 GPS sensors on the mountain. The exact number of sensors varies over time because the eruption basically destroys some of them. The sensors revealed that all of Etna is sliding. The annual rate varied from about 10 millimeters to about 17 millimeters a year, averaging about 14 millimeters. The rock that Etna sits on, known as the basement, is made of weak, flexible sediments. So the whole mountain is thus sliding downhill on this basement, and it's the first time an entirely active volcano has been observed sliding along its basement rock. If the sliding slows in the future, Murray continues, it probably won't cause any problems. If it accelerates or keeps up its pace, however, it could result in enormous landslides. A similar process occurred on the volcano of Socompa in Chile more than 7,000 years ago, leaving a huge debris deposit. The Colima volcano in Mexico also bears the scars of huge slope collapses. Now, this is kind of interesting because we have an interesting situation going on in Hawaii with Mount Kilauea. Okay? Mount Kilauea, as you probably have seen in the news, is having lots of lava flows, and the lava is spreading and is spewing and so on and so forth. Now, Kilauea and Etna are two different types of volcanoes. Etna is what's called a cinder cone volcano, where it tends to erupt with, gas buildup occurs and there's an eruption and a lot of material is blowing up into the sky. Think of Krakatoa when that blew up, or Mount St. Helens, for example. Kilauea is what's called a shield volcano. So shield volcanoes tend not to be explosive, but they tend to ooze a lot of magma, and when magma reaches the surface, it's called lava. So it tends to ooze a lot of lava, and the lava will then stretch and spread out, cause trees to catch fire, and so on and so forth. And if your home is in the way, you'll find you have lava coming through your living room. But anyway, the interesting thing is, if you look at the Hawaiian island chain, it's formed over a hotspot plume of magma rising to the surface, and then magma rises, the volcano grows inside, but plate tectonics also moves the islands off of it, so that you form an island, the plates move it, then the plume's still active, and then you get the next island, and so on. Well, here's an interesting thing about Kilauea. And specifically, if you look at the location of this latest eruption, it's in the southeast portion of the Big Island. There was a TV program called How the Earth Works, and there was speculation in an episode of how Hawaii could destroy LA. The presenters showed evidence for a 20-mile section of the southeast portion, same spot where this is going on, of the Big Island had separated and sunk about 10 feet, 3 meters or more or so. This behavior tends to be consistent with older islands of the Hawaiian island chain. So it leads one to wonder, can something similar happen? Could this southeast portion once again let go and sink? Because when it sinks, we're talking about a slide. And you know what that means? You form a tsunami. And the tsunami will then travel across the Pacific towards LA. The current eruption of Kilauea is showing huge fissures opening up in the southeast section of this Big Island, just as presented in this program. This will be very interesting to see what comes of this. The next story involves West Texas. Is West Texas sinking into a hole of its own making? Parts of West Texas are sinking, other parts quaking and shaking, thanks to oil and gas extraction. Right? Go a little bit north of Texas to Oklahoma, where they're having numerous earthquakes, all due to fracking activities. A new study using satellite data to measure ground changes near Pecos, Monahans, Wink, and Kermit, Texas, finds multiple disturbances, including places where the ground is sinking up to 10 centimeters a year. In one spot, the ground dropped so much that it formed a new lake, Lake Bomer. This area of the oil-rich Permian Basin is relatively sparsely populated, but hydrocarbon extraction there is booming, and the area is crisscrossed with roadways and pipelines for moving the oil and the gas. This network is extremely dense, said study researcher Jean Liu, a geophysicist at Southern Methodist University in Dallas. This infrastructure is threatened by the shifting ground. The team focused, Dr. Liu's team focused on a 100-mile by 100-mile, 160 square kilometers, in West Texas, just south of the New Mexico border and slightly southwest of the cities of Midland and Odessa. Within that square, they searched for changes of at least centimeters per year that covered areas of between 200 square meters and 2 square kilometers. They found many. In two areas, the ground was actually rising slightly. At two wells on the border of Winkler and Loving counties, the surface had risen basically 5.5 centimeters over the study period, probably due to the injection of wastewater from well drilling below the surface. Similarly, part of the North Ward Estes field, which is in Ward and Winkler counties, saw an uplift of just over 3 centimeters, likely due to the injection of carbon dioxide into the rock to pressurize the reservoir and enhance oil recovery. In many other spots, the ground was not rising but sinking. Near Wink and Imperial, Texas, old wells that have been abandoned but not properly plugged with cement have allowed fresh water to seep into the ground, dissolving salt formations deep under the surface. As voids open up underground, they can cause the surface to sink or collapse. Near Wink, a sinkhole opened up in 1980 and another in 2002. The ground around these sinkholes is still dropping by about 4 centimeters a year, Lou and his colleagues found. Near Imperial, subsidence from leaky wells that were in some cases drilled 50 years ago have caused major problems. Balmer Lake is a brackish body of water just south of town, did not exist until 2003. Now, brackish means it has salt content in it. Estuary waters are brackish. They don't have the salinity of open oceans, like about 33 or 34 parts per thousand. It's probably, the salinity is more in the 15 to 25 parts per thousand range, depending on what part of the tidal cycle you do your measurements on. So this brackish water makes sense because of dissolving salts, so the salt goes into solution, so that makes sense. Other examples: Farm to Market Road 1053 near the lake is sinking by 10 centimeters a year. The road has been closed due to this instability. At the Santa Rosa Springs southwest of the town of Grand Falls, the ground is also dropping. The surface level has dropped by 23 centimeters. That's almost 30 centimeters, about a foot. So we're talking about 3/4 of a foot since 2014 in total. This is from the satellite data. This subsidence is most likely caused by the dissolution of salt formations below the surface. Although researchers are not exactly clear on why the salt is dissolving so rapidly. Finally, the research team discovered about 4.5 centimeters of subsidence at Wolfbone Field, south of the town of Pecos. This field has also been the site of 6 small earthquakes, 1 in 2015, 5 in 2017. The ground is likely slumping at Wolfbone Field because of the large amount of oil removed from the subsurface since 2015. Lou and his team wrote in the journal Scientific Reports. The same changes could make tremblers more likely. So, in essence, by removing material, injecting wastewater or water dissolving salts, we're changing what's happening underneath, and the result could be ground sinking. We've already seen an immense increase in earthquake activity in Oklahoma due to fracking. We're now seeing parts of Texas having issues with the ground underneath there due to hydrocarbon removal. North Dakota, there's a lot of fracking activity that takes place there. It'll be interesting to see if, over the course of the next few decades, if North Dakota experiences similar issues. So, what does this mean? We need to watch what we're doing. We really need to be developing alternative energy sources. Wind, solar. That's what we need to really be doing. And as the cost of, say, solar panels for residential use decreases, this will help create more jobs in those sectors so that hopefully we can move off of the hydrocarbon-based system for our energy usages. So I wanted to bring you these stories of how the forever moving earth around us, both done by nature and done by human activity. Please share this video. Please consider becoming a patron at my Patreon page, patreon.com/Science Talk with Jim Massa. If you are already a patron, thank you for your support. Please share this video. Please tell others of my work. It is through your word of mouth that my channel will grow, and this needed information that has to be gotten out there can be made more accessible to more and more people. Thank you for your time.